The reciprocal function f of x equals 1 over x maps every non-zero real number to its reciprocal. To graph, you can start by calculating a few points. When x equals 1, the reciprocal of 1 is 1. When x equals 2, the reciprocal is 1/2. When x equals 3, the reciprocal is 1/3. When x equals 4, its reciprocal is 1/4. As x increases toward infinity, the reciprocal values decrease, approaching 0 but never actually reaching it. Similarly, when x is 1/2, its reciprocal is 2. When x equals 1/3, its reciprocal is 3, and so on, illustrating how smaller x values lead to larger reciprocals. As x approaches 0, the graph approaches the y-axis, but never touches it, as x equals 0 results in an undefined value. This pattern holds for negative x values as well. The graph of the reciprocal function features a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. The domain of the function consists of all real numbers except 0, and the range includes all real numbers except 0. Transformations of the function involve horizontal and vertical shifts. Subtracting h from x shifts the graph horizontally, resulting in a vertical asymptote at x equals h, while adding k to the function shifts the graph vertically, moving the horizontal asymptote to y equals k. Let's graph g of x. Then write the equations of the asymptotes, the domain, and the range. We can start with the parent function f of x equals 1 over x. The x minus 3 shifts the graph 3 units to the right, moving the vertical asymptote to x equals 3. The plus 1 shifts the graph 1 unit up, moving the horizontal asymptote to y equals 1. Therefore, the graph of g is the graph of f translated 3 units right and 1 unit up, with the vertical asymptote at x equals 3 and the horizontal asymptote at y equals 1. The domain is the set of all x such that x is not equal to 3, and the range is the set of all y such that y is not equal to 1.